Welcome back to day 2 of Elimination Method. I hope you guys like this method of solving for the systems. I do. I like adding them up and canceling out one of the variables. So today, this is our second day of it. What we have to do to create those opposites, just a little bit more challenging, okay? So if we take a look at, I have 3x, 5x, not quite close to being opposites. 5y, 7y, again, not quite close to being opposites. So you really just have to pick one of your numbers, 3 and 5 or 5 and 7, and find the least common multiple. So I'm going to go ahead and work with 3 and 5. And the least common multiple is 15, a number that they both go into. So when I multiply 1, I'm going to multiply 1 by 5, the other one by 3, but then again one of them has to be opposite. So I'll have a negative 5 and a positive 3. So make sure you multiply every term by that negative 5. So we get negative 15x minus 25y is equal to negative 50. Then 3 times 5x is 15x, 3 times 7y is 21y, and 3 times 10 is 30. Okay, so again, I multiplied each number by a term, and I have created opposites. So negative 15x plus 15x cancel out. Negative 25y plus 21y is negative 4y, is equal to negative 20. I divide both sides by negative 4, and I have y equals positive 5. And then from here, we just pick one of the equations, substitute 5 in for y. So I'm going to go ahead and take 3x plus 5, and again, instead of writing y, I'm going to substitute in that 5 equal to 10. And so we get 3x plus 25 equal to 10. Subtract both sides by 25. I have 3x is equal to negative 15. X is equal to negative 5. So in this case, I have one solution with the ordered pair of negative 5, 5. Okay, let's go ahead and try this again for number 2. So for number 2, again, we need to create opposites. 15, 10, 7, and 3. It doesn't matter which sets of ordered pair, or not ordered pairs, but variable terms you want to work with, because we're going to have to multiply both equations by something. I'm going to go ahead and work with x's again, just because. And so we'll go ahead and multiply the top one by negative 10, the bottom one by positive 15. I did not mean to put the negative in there. There we go. And then again, we multiply every term by negative 10 for our top equation. So when I do that, I get negative 150x. And then negative 10 times 3y is negative 30y. Negative 10 times 9 is negative 90. Then 15 times 10 is 150x. 15 times 7 is 105y. 15 times negative 4 is negative 60. I have created my opposites, so when I add these two equations together, the x variables do cancel out. Then I just do negative 30y plus 105y, I get 75y. And then I add together to get a negative 150. And divide both sides by 75. Y is equal to negative 2. And then again, pick one of your equations, doesn't matter which one, we're going to substitute negative 2 in for y. And so I'm going to go ahead and just pick the top one. Really, you can pick what you think will be easier for you to work out. So I end up with 15x minus 6 is equal to 9. We add 6 to both sides. 15x equals 15, x equals 1. And so this is a one solution with the ordered pair 1, negative 2. Okay, moving to number 3 and 4. We'll do those together next time I see you in class. That way I want to make sure you get a good understanding of this increased challenge with elimination method. But we can go ahead and start this first story problem number 5. So for problem number 5, I have the sum of two numbers is 18. The sum of the greater number and twice the smaller number is 25. Find the numbers. So the first thing that we're going to do is label our variables. I'm going to go ahead and use x and y. They talk about a greater number and a smaller number. So those are the two things that I'm going to compare. So it doesn't matter which one, just assign one of them as larger and smaller. So I'm going to go ahead and do x is the smaller number, y is my larger number. Now we have to create those two equations. The first sentence says the sum of two numbers is 18. So I can take my two numbers, I'm going to add them together and make that 18. The sum of the greater number and twice the smaller number is 25. So the sum of the greater and twice the smaller. So that means that I'm going to have to double the smaller one. So that'll be 2x. Again, it's still sum, so I'm going to add it together, and it's 25. This is my system of equations, and this is what I'll use to go ahead and solve. So for this one, I'm going to go ahead and have to multiply. You know, actually, yeah, we're going to go ahead and work with elimination methods still on these. And so I'm going to multiply one of my equations by -1 so I can cancel out my y. So I'm going to go ahead and multiply that top one by -1. That's going to look like -x minus y is equal to -18. So a reminder, every term is getting multiplied by -1. I'm going to just carry over 2x plus y is equal to 25. And then I can go ahead and add this up. -x plus 2x is a positive x. My y's cancel out. And then 25, -18 plus 25 is 7. And then all I have to do is pick one of my equations, substitute 7 in for x. So I'm going to go ahead and just pick the top one. And when I pick the top one, it's going to be 7 plus y equals 18. So y is equal to 11. And so I'm just going to write out that the smaller is 7. And the larger is 11. Okay, so there are two story problems on the back. Same thing, I'm going to wait until class, and I'm going to do those with you just so we get a good grasp on those. Okay, that's it for these notes. Thanks, guys.